So, under the types of reactions, the last reaction is elimination reaction. Elimination reaction is basically can be explained like this: one H and the Cl of a ethyl chloride is being removed. The removing molecule happens to be an acid. So, we can have a question: what type of reagent can drag away or remove the HCl molecule from the compound? Means a strong base should be used, right? This is the answer. A strong base is the right chance to grab away this. HCl is an acid. So, acid I want to take a water, sulfuric acid or anhydrides are used. Just like that, how the HCl can be removed means the answer comes as a strong base. What is that strong base means? Generally, we take a potassium hydroxide in the alcohol. Now, why alcohol means we have a small the doubt also here. The same KOH when I dissolve in the water, that is called aqueous. Water dissolved potassium hydroxide will do another type of reaction, that is OH. This is a nucleophilic substitution reaction is taking place. Okay. So, therefore, one must be very careful in writing this alcohol. KOH, it is not a KOH is available in the form of solid, but dissolve in alcohol, prepare a solution of the alcoholic alkali, then heat it for some time. This happens to be the stronger base than the KOH dissolved in the water. Mathematically, we can say the more the water you add, the strength of the KOH is going on decreasing. There also mathematically, if KOH go on, add alcohol, KOH concentration decreases, but alcohol and KOH think that it is a reaction taking place, alcohol becomes into alkoxide. So, the alkoxides are stronger bases than the hydroxide. So, therefore, the alcoholic KOH is shown and also believed to be the stronger base than the aqueous KOH. So, that is why a strong base will remove and you are getting a CH2 and the CH2, a double bond is formed. The removed HCl will react with the KOH, forms KCl and the water. So, this is the elimination reaction by removing the two groups and we are getting the double bond. In this two groups, which group goes out? Based on that, we do not have a mechanism of electrophilic sub elimination, nucleophilic elimination, free radical elimination, but elimination can be classified into three types. Elimination is classified into three types: elimination with bimolecular, elimination with unimolecular, elimination with unimolecular CB. So, there are three types of eliminations are there, and let us see now the elimination bimolecular. E2 mechanism stands for the bimolecular elimination. Bimolecular elimination. This elimination is very much close to the SN2 type of reaction. In this reaction, let us have a smaller molecule only, like a HCl containing molecule, that is ethyl chloride. We can recognize this is the HCl, I am going to remove it. But I need a what? A strong base like a KOH. So, the OH minus is going to remove this H plus as initially. So, the OH minus is going to take away the H, leaving the two electrons only. So, why it is so happening means the Cl is pulling. So, it has got a minus inductive effect. In fact, if somebody asks that when Cl is pulling, the C also pulls, the hydrogen will acquire some acidic nature. This carbon will pull, this carbon will pull, even this hydrogen will have acidic. Out of these two hydrogen, which is more acidic means in fact that only. But if I remove the H and Cl from the same carbon, you get a carbene. So, therefore, the removal of the H always from the beta carbon is always more ready than the alpha carbon. That is why when chlorine is pulling, the carbon will pull and this carbon will pull, the hydrogen will come out as a H plus. the remaining 2 electrons of the bonded electrons will be shifted to this side, and these 2 electrons are shifted to the Cl. So, let us call the removal of the H as a step, the 2 electron shifting is a B step, and these 2 electrons withdrawal is a C step. This A, B, C will take place simultaneously. It is possible. They synchronize because the H removal is by the OH minus. These 2 electrons are pulled by this bond, and these 2 are pulled by this. They are all individuals. So, therefore, there is no, that is it cannot be simultaneous. All A, B, C can be simultaneously, they are not individual steps. All 3, that is the OH taking out the proton and the 2 electron shifting to make a pi bond, the 2 electron shifting and the Cl minus is left. So, all in one time takes place. A double bond is formed and the removed the H plus and the OH forms into water, and the Cl minus and the K plus what we have taken becomes into the KCl. So, this is all in one step only. Number of steps involved in the reaction is only one step, that is all, single step reaction. Or do you have a stepwise mechanism in this? Means no. So, therefore, you too can say it is a no step mechanism. It is a no steps mechanism. It is not a stepwise mechanism. No steps are involved, or only one step is there. This is the step naturally will decide the rate of the reaction. So, what is the rate determining factors? Means in the rate that is deciding, one is ethyl chloride, the other one is concentration of base. Both are influencing the rate of the reaction. So, therefore, the rate of this elimination is directly proportional to the concentration of the alkyl halide as well as the concentration of the base. Both concentration multiplication factor is the directly influencing the rate. So, that is why it is called bimolecular. Just like in SN2 reaction, the alkyl halide base both are influencing, that is why I called SN2 type of. Here also the base and the alkyl halide both are involved in this step. This happens to be only one step. So, in that step both are. So, either one concentration you increase, that is collision chances increase, therefore, rate increase. If you decrease any one concentration, again rate decreases. That means the rate is influenced by the both the constant. That is why I call it is a E2 type of the reaction. The reaction is very simple. Ethyl chloride when treated with alcoholic KOH becomes ethylene in one single step, and this happens to be a rate dependent on the both. So, therefore, I call it is the E2 type of the mechanism. It is a bimolecular elimination reaction, right. Now, similar to this bimolecular, let us go for the unimolecular elimination, that is E1 type of the reaction. Let us take a E1 mechanism, that is unimolecular elimination mechanism. In the bimolecular mechanism is also we can have a one approach. The OH is coming and would like to take the H. If it comes really very close to the Cl will have a delta negative, therefore, it will oppose. It has to come from the little away from the Cl, or from the other side. If it comes, there is no problem. If it comes from the other side other than the Cl side, it is okay. Or if you want to come from the Cl, means little away from the Cl but not from the closer side. Similar the explanation if I give, there is a chlorine and there is a hydrogen. These two I am going to remove net. But if this carbon has got all the big groups, that means the halogen attached carbon is a 3 degree, where hydrogen is also attached is a 3 degree. So, specifically the halogen compound is a 3 degree alkyl halide. The halogen compound I have chosen is a 3 degree alkyl halide. Previous one is a 1 degree one. When 1 degree alkyl halide is taken, E2 mechanism is taking place. When 3 degree is taken, what happens? Let us see. So, in the even elimination, we have taken a tertiary compound. So, as usually the OH would like to come from the side of the Cl, but the Cl is delta negative. So, therefore, it will have a repulsion. So, therefore, the OH either has to come from the away, or when it is coming from the other side. The alkyl groups now, the size of the alkyl groups are so big when compared to the hydrogen. So, the hydrogen, though I have written almost the same size right now, but the virtually if you see the size of the alkyl versus hydrogen, hydrogen size will be very small. So, it is having only 1 electron, 1 proton when compared with the alkyl. Minimum alkyl means also 1 carbon, 6 electrons, 6 protons, 6 neutrons and the 3 hydrogen. So, minimum 15 times it will be bigger and then the hydrogen. So, therefore, the size of the hydrogen is very small, all these alkyl groups are covering. So, therefore, the tracing the OH, that hydrogen or taking that hydrogen will be difficult. This problem we have seen in SN2 reaction, SN1 reaction as a steric hindrance. Due to the steric hindrance, the OH minus cannot take away this hydrogen, but we have other features are supporting this reaction. All these alkyl groups are pushing. So, therefore, outgoing property of the Cl will be more now. That means taking the hydrogen is not possible, but first Cl will go away. In this reaction, first hydrogen is going. So, what goes first also you can note in E2 hydrogen as a H plus going first. In this reaction, Cl minus is going first, minus of Cl. This step I call it as a ionization of alkyl halide. This happens to be slow step in fact. Then once this carbocation is formed, the Cl is lost. So, this will become a carbocation. What is the symmetry of this carbon? It is right now tetrahedral, but when once the Cl goes, this carbon will acquire a trigonal planarity, but the second carbon where hydrogen is there still will have that tetrahedral problem. So, now this the OH minus is if it is coming from this side, let us say there is no chlorine, that is which says negative repulsion, and it has a plane. Therefore, from the back side it is problem, but from the front side the plane of the carbon will be a plane. So, with reference to the plane, the OH can come from this side or from that side and reach the same the H plus and take away this H plus. So, when H plus is lost, the 2 electrons will be given and then double bond is formed. So, this side 2 alkyl groups, that side 2 alkyl groups, and alkene is formed, and the H plus and the OH forms into water. So, the OH minus take that H, so H2O is formed. This is step 2. In the step 2, the reaction is fast when compared with this one. So, the entire rate in the kinetics we see when a reaction takes place in 3-4 steps, the step which is the slowest will be the deciding factor of that completion of the reaction. So, therefore, this slow step will be the rate determining step. So, rate of the reaction depends on the ingredients or the participants of this reaction is only one alkyl halide. What about the OH minus? Means OH minus is coming in the second step. So, therefore, the little more amount of OH if we add also, the reaction, the kinetics are the increasing the rate you do not find. So, that is why the rate only dependent on the alkyl halide, that is one molecule concentration only. That is why we call it as a E1 mechanism. 1 stands for the one molecule concentration alone will be deciding the factor, that is why E1. Here this is only one step. In that step the base attacking and this alkyl halide is being attacked. So, both concentration is influencing, that is why it is called. Okay. However, it is classified E2, E1 based on the kinetics of the reaction, but with reference to the previously in the addition reaction first attacks what first attacks? Electrophilic addition, nuclear. Like that here also, what goes out initially in the first means H plus is going out, isn't it? H plus and Cl both are going out. In the E2 mechanism, H and Cl both are simultaneously going out. So that is called E2. In this reaction, first the Cl minus is going. So therefore, in the first Cl minus is going. So carbocation, this is called what? Intermediate species. Intermediate species is carbocation. Carbocation. If at all, first H plus goes out, leaving the 2 electrons, carbanion is formed. That makes another mechanism. Both goes together is E2 mechanism. First Cl minus goes, carbocation is formed. This is E1 mechanism. First only H plus goes. Imagine that only H plus goes, a carbanion is formed. That is another type, third type of reaction, that is E1Cb type of the reaction that we will take now. So let us take the third mechanism, E1Cb. What does it mean? 1 stands for the unimolecular, same, elimination unimolecular through conjugate base. Okay. So I will write elimination unimolecular through its conjugate base. Conjugate base. What is the conjugate base means? An alkyl halide undergoing this reaction. So therefore, conjugate base of what? Alkyl halide only. In ethyl chloride, if you remove the H plus, what you get is called a carbanion. Any substance, if you remove H plus, for example water, remove the H plus, what you get is called the conjugate base of the water. So water is the compound, its conjugate base is, after removing the H plus, what you get is called conjugate base. So therefore, this is a elimination reaction of which compound? Alkyl halide. So the alkyl halide remove 1 proton, what you get? Conjugate base. So that is what happening here. So ethyl chloride I have taken, leave the groups here, 1 H I am removing. To what? To get the carbanion. So in the step 1, what we are doing is a removal of the H plus, minus of H plus, that's all. Not both simultaneous. In E2 mechanism, H is removed, 2 electrons are shifted, Cl will go simultaneously. No, here only H is dropped. To get what? To get a carbanion. So therefore, when this reaction takes place, the answer is whenever this carbanion is stabilized, a stable carbanion, whenever it is formed, the reaction is going to take place. When the carbocation stabilizes, the more the alkyl groups, more will be the stabilization. Alkyl groups are plus inductive effect, or if any alpha hydrogens are present, they show hyperconjugation. So carbocation is stabilized. If there is a double bond or a lone pair or a conjugated systems are available, they show the mesomeric effect also. So therefore, carbocation will be formed whenever in the intermediate of that carbocation there must be some groups which stabilize the carbocation. Similar the case also here also, when this H plus goes out in the step 1, when this carbanion is formed means whenever the carbanion has stabilized. So you must have such a group that must stabilize this carbanion. The group should have the strong minus I features. That is an example, you can have a fluorine directly. A group can be fluorine. A group can be a benzene ring even. Benzene will have just like if a carbocation is there, the benzene acts as a plus M group. But if a carbanion is there, carbanion electrons can be withdrawn like this and it acts as a minus M group. Even benzene can stabilize. Benzene having a minus I group, let us say a group, the benzene itself is a minus M group and it attached with either with minus I or with the minus M, that is like a nitro group. So, a benzene is a minus M group attached with a nitro group at a suitable position at ortho or para. Meta will not become the active, but either at ortho or at para. If a strong withdrawing group like nitro groups are there, it will be useful. Similarly, we have a CF3. This is called a hyperconjugation with minus. Minus hyperconjugation showing groups also will stabilize this carbanion. So, the carbanion which is having a suitable group, what is that group? Either can be a direct fluorine or a benzene. Benzene having a minus I groups or minus M groups or a CF3 type of groups will stabilize this carbanion. A stable carbanion, if it is formed, then it undergoes the minus will be attacking here, the Cl is withdrawn. So, this is called what? A conjugate acid. Conjugate base of ethyl chloride, right? Ethyl chloride, from the ethyl chloride, if you remove the beta hydrogen first, you get an anion. That carbanion is known as conjugate base. So, it is also even mechanism, because in this reaction it so happens in the second step Cl is going. So, therefore, a double bond is formed. The Cl will be removed here. The second step happens to be the slow step. That means the H plus removal will be fast because it is stabilized carbanion. A stable carbanion is formed because, as I said, some stabilizing features are attached to this carbanion. So, it is stable means the reaction will become a little faster only. So, therefore, the second step happens to be the slow step, or this is called what? RD, or rate determining step. In this step, how many species are involved means this is the anion concentration is influencing, because the base is attacking in the first step only. The OH minus is taking away the proton in the step 1 only. That happens to be the faster one. So, therefore, the slow step is rate determining, in which the conjugate base is expelling the Cl minus and becoming into double bond. So, only one. So, the rate of the reaction is directly proportional to the only one molecule, that too conjugate base of alkyl halide, not the alkyl halide. Conjugate base of alkyl halide means from the alkyl halide, from a beta carbon, if you remove proton, this anion is formed, that is called the conjugate base of the alkyl halide. So, the second step happens to be the slow one, and that too, in that only one, that is concentration is influencing. So, it is a unimolecular elimination, and it is also called the what is the that is rate determining the concentration, means the concentration of the conjugate base of the alkyl halide. Therefore, it is called elimination unimolecular through conjugate base, right. Now, the classification E1, E2 and E1CB is basically on the kinetics, that is the rate determining steps, rate determining on the both the molecules E2, that is ordinary alkyl halides undergo that. A tertiary alkyl halide becomes a carbocation first, because the stable carbocation intermediate, that is even mechanism, in which rate determining step is only alkyl halide alone will decide, not the base, because base is coming in the second step. The step 1 happens to be the slow step. So, in this OH concentration is not influencing, therefore, the reaction takes place in that way. In this third reaction, third type of reaction, it is again unimolecular only, but the rate of reaction is influenced by the only the conjugate base of the alkyl halide. Therefore, it is called unimolecular conjugate base. You too can have in the other way of understanding. In the first E2 mechanism, H and Cl going simultaneously, H and Cl going simultaneously, H plus Cl minus left simultaneously. In the E1 mechanism, first Cl goes and become a carbocation. In the E1CB, first H plus goes, becomes a carbanion. So, therefore, there are two ionic mechanisms are there. Through carbocation means E1 mechanism, through carbanion means E1CB. Both removed simultaneously means it is a E2 elimination.